Hey, and welcome to Lyto for Developers, where I give tips and knowledge to my programming colleagues. Today I will be talking about the 5 subcategories of computing. Let's get started. To those new on the channel, my name is Mateo and I studied mechatronics engineering, but I also study on my free time software by my own using online courses and so on. During the past years, I've been hearing different terms like computer science, computer engineering, software engineering, and I never had clear what were the similarities and differences between these. And I think there is many people out there, especially students that are gonna study now a degree, that don't really know the difference between each one, and in such an important decision, we should all have a clear idea of what is different computer science from software engineering and so on. So I went on the internet and I did some research, and people on the internet actually seem to be as confused as me about these terms. Finally, I found one place called the Association for Computing Machinery that clarify all my questions, and I think will clarify all the questions of those that already finished a degree and are still wondering about this, or those that are aiming to study or aiming to start a career on something. So apparently this is the oldest computing society and the most respected and relevant one. It seems to be the one that defines the standards and leads our professionals. They have subdivided the whole field of computing into 5 subfields: computer engineering, computer science, information systems, information technology, and software engineering. They define each field, their similarities, and also the boundaries between each other. Obviously, each country and university creates their own degrees and standards, but they all look and fall within these 5 subcategories, so it's worth to take it a look. This report brings us a graph defining the interests of each field and their limits. In the x-axis, we've got from theory to practice. So closer to the 0 point, we've got the theory. For example, the theory with algorithms, how to implement architecture in a computer, and so on. And to the right, we've got the practical things. So the applications of software for solving problems, for example, Just Eat or Uber, creating websites for clients, and so on. In the y-axis, we have 4 categories from top to bottom: organization, application technologies, software technologies, system infrastructure, and computer hardware. It goes from the top, focused more on organizations and people, to the actual devices and data. So without further ado, let's get started with these 5 subcategories. Computer engineering. This is a branch of engineering that integrates several fields of computer science and electronics engineering required to develop computer hardware and software. It's basically the disciplines that combine the hardware with softwares. It includes some fields of electrical engineering with some others from computer science. This goes from embedded systems to microprocessors, passing through input and output systems or networking components. They develop the configuration that connects software with hardware, basically. Their interest in software is for integrating devices with the hardware. So everything that has to do of software that has to interact with a physical thing, that's for computer engineering. As we can see on the graph, computer engineering covers the whole aspect of computer hardware and architecture, and it narrows towards the top as it also covers a bit of software, methodology, and system infrastructure. Computer science. This is the study of processes that interact with data and can be represented as data in the form of programs. They're more focused on the theory and development of software. This degree is not so centered in the applications or deployment of the software, but mainly focused on creating it and creating the best they can. From algorithms to databases, it covers most software fields, including operational systems, networking, time complexity, analysis, development, fundamentals, and so on. As we can see on the graph, they are more focused on theory than others, and they cover most of the software fields in the y-axis. Information systems. Information systems are formal socio-technical organization systems designed to collect, process, store, and distribute information. What does this mean? Well, they basically cover the operations and manage some business and financial aspects of software. They deal with deployment and their practical use of system infrastructure for companies, as well as user training. They basically manage the relationship between information systems and the companies they serve. One field they notably work with is databases. To summarize it in 2 words, it would be called management and data. In our lovely graph, we can see how this is a very practical field, and it covers also the whole aspects of information systems or organizational issues. It also covers the practical things, the practical techniques of software. Information technology. This is the study of systemic approaches to select, develop, apply, integrate, and administrate secure computing technologies to enable users to accomplish their personal, organizational, and societal goals. This is broadly known as IT. It's a very practical subfield focused on satisfying human needs. Its pillars are programming, networking, human interaction, databases, and web systems, overlapping some areas with information systems. This has led to people confusing one with each other. It has rapidly progressed in the past years, including some other areas, but keeping its practical nature, covering from methodologies of organizing teams like Agile or DevOps to the application of technology and information. As I already said, and that's something that we can see in the graph, this is fully practical, the most practical category of all, covering all aspects apart from hardware and getting closer to theory in application technologies, but nothing compared to the rest. This is basically a practical category, a practical career. Software engineering. This is the application of engineering to the development of software in a systematic method. This means that they mainly cover everything related to produce high-quality software on time and within the budget. So this is also a kind of practical thing. It covers a bit of software infrastructure as well as developing software appropriate for companies. It designs, develops, maintains, tests, and evaluates of computer software. It's more based on real world compared to computer science. So in software engineering, you're gonna apply more your knowledge, your practical knowledge to the real world, compared to computer science, where you also see the theory and where you also focus on algorithms, on databases, and so on. As we can see on the graph, it covers basically the center, covering a bit of theory of software methods and technology, and mostly a mix between practical things with a bit of theory. So those were the main 5 subcategories out there. And others are even considering using cybersecurity and computing security as a new category. This is because their careers and people working on this are becoming more and more relevant, and we'll probably see in the future degrees focus on this topic. I hope this has helped you to clarify your ideas about what fields, what options are there to choose for your career, for your degree, and which one would fit best for you. And don't worry if you don't understand it now, it's a bit complex and quite ambiguous. The main important thing is to get the main concept of each field. Obviously, each category, each area has their own subfields, and I'd like to go deeper in another video into each category and talk about their own subfields, what should you pick if you want to do a certain degree or you're interested in a certain topic, but those for next videos. To be honest, I thought these reports from this society would be way more difficult to understand, but they're actually quite simple, easy to understand even for people that don't use technical terms like me, and it's worth it to take a look at them, and because they really help you get an idea of the standards, to get an idea of what is each thing. I will leave down the links in the description for the whole report covering the whole computing aspect, as well as each subcategory field report. So I hope you enjoyed this video. If so, leave a like, subscribe to our channel, and see you on the next one.